pH calculations. We are going to take a quick jaunt through pH calculations so that you know all of the equations associated with pH calculations as well as how they relate to one another. We're going to start with the pH scale. The pH scale is based on the concentration of the hydrogen or hydronium ion in an aqueous solution. pH, P standing for negative log, and H standing for hydroxide solution. So we take the negative log of the, I think I just said hydroxide, I meant hydronium. We're going to take the negative log of the hydronium or hydrogen ion concentration, and that gives us our pH. If we look at the scale, everything from 0 to 7 is considered acidic. Everything from 14 down to 7 is considered basic, and 7 is of course neutral. In this scale right here between 0 and 7, it's acidic because there is a higher concentration of H plus than OH minus. At the basic side of this scale, there is a higher concentration of hydroxide than hydrogen ion, and at neutral, the two concentrations are equal. In addition to the pH scale, there is also the pOH scale. pOH can be useful if you are working in a basic solution and you know the hydroxide ion concentration. You can use that equation to figure out the hydrogen ion concentration. Then for both of these, if you needed to travel back from pOH to the hydroxide ion concentration, you would use 10 to the negative pOH or 10 to the negative pH to essentially undo the log. All right, we've got our four basic equations, and then we're going to relate them. pH and pOH, when added together, yield 14. All the time, every time. Assuming that's for the same solution, obviously, they add to be 14. If I take the hydrogen ion and the hydroxide ion concentration of the same solution, they will multiply together to equal Kw. Kw is 1 times 10 to the negative 14th, thus the scale 0 to 14. So from any one of these equations, you can get to any of these other quantities. So you might be asked for hydroxide ion concentration, hydrogen ion concentration, pH, or pOH. And by combining all of these equations, you can get from any one of those four to any of the other three. Now, our favorite topic, significant figures. So, pH, as we've established, is a logarithmic value. So, when we are talking about which of our figures are significant, numbers that are after the decimal are considered significant. So if I'm given a value of 1.57 for my pH, that means that I have two significant figures in this value. So if I'm given this value and asked for, say, hydrogen ion concentration, my final answer should then have two significant figures in it. Again, after the decimal place. The reason for that is that this number in front is essentially telling us how big or small the logarithmic value is. It's not adding to the precision of the number. That's the very basic explanation of that. Remember, it applies to pH values and pOH values. Let's do some calculations. First, we're going to determine the pH for each of these, and then we're going to evaluate if it's an acidic solution or a basic solution. So the most straightforward, if we have the hydrogen ion concentration, then to find the pH, all we're going to do is take the negative log of that number. That is going to give us a value of 8.3979 blah 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 blah. Sig figs here. We need one significant figure, and that is going to be 8.4 is our pH for part A. Remembering that this first number is not significant. That's our first pH. I'm going to come back and evaluate this at the end. Next up, we're giving the hydroxide ion solution. There are multiple ways to go about this. I'm going to start by calculating the pOH and then converting that to pH. So the pOH is the negative log of the hydroxide ion solution, and that's going to be 8 exactly. Then I take my equation pH plus pOH equals 14. I'm going to take 14 minus 8. That gives me that pH equals 6.0. Lastly, I'm given the pOH value. I need to get to pH. I'm going to use the same equation here. I have pH plus 4.5 equals 14. So subtract 4.5 from both sides. That gives us a pH value of 9.5. So let's go through and evaluate if it's acidic or basic. Our first pH is greater than 7, so this is going to be basic. Important to note here, if I look here, my ion concentration for hydrogen has a number that's greater than 7, so 10 to the negative somethings greater than 7. That's a good indication it's going to be basic because I have a very small concentration of hydrogen ions. Part B, we have a pH of 6. So this solution is going to be acidic. Here again, we see that the hydroxide solution has a very small molarity. The 10 to the negative power is greater than 7, so that makes sense that there's less hydroxide and more hydrogen ion, making it acidic. Here we have a pOH of 4.5 and a pH of 9.5. This is going to be a basic solution. All right, you've been introduced to pH and pOH, the fact that they exist on a logarithmic scale, and that you can convert between pH, pOH, hydrogen ion concentration, and hydroxide ion concentration using the equations that we've got. I highly recommend that you go to your equation sheet and just take a look at where they are located on the equation sheet and in what forms. All right, bye.